Dear students, we have been discussing lot of questions about this continuity. Today also we will be discussing the same question, but the today's question is bit different. So try to see. And you are given suppose a question, prove that or discuss the continuity. Discuss the continuity. Discuss the continuity of the function f(x) equals to mod of x minus mod of x plus 4. See how to solve this. First we say to define mod of x is what? Mod of x is x when x is greater than equal to 0 minus x when x is less than 0. This already we have discussed. Okay. Now look at here. What will be mod of x plus 1? If you look at this, look at here. Mod of x is x. So mod of x plus 1 will be x plus 1. Here x is greater than 0. So we will have x plus 1 is greater than equals to 0. That means we will have x is greater than equal to minus 1. Again you see mod of x is minus x. So mod of x plus 1 will be minus x plus 1 where x plus 1 is less than 0. Like x is less than 0, so x plus 1 will be less than 0. So this implies x is less than minus 1. Now look at here. This is minus 1, this is 0. Because you are getting a point 0, you are getting a point minus 1. So now we will discuss about this. So when anything will be less than 0, you are going this side. So we will understand everything from this number line. Suppose, first of all, we will take from here, one is x is less than 1. One is between minus 1 and 0 and other one is greater than 0. Three parts we will have. One part x is less than 1. Other part x between minus 1 and 0. Third part is, what will be the third part? Third part will be x is greater than 0. So look at here. So first we'll consider this when x is less than minus 1. Okay. What will be the value of mod of x plus 1? Sorry, mod of x minus mod of x plus 1. Okay. Now look, when I say x is less than minus 1, you are going this direction. So if you are going in this direction, that is the direction of 0 also. I can say x is less than 0. When I am going x is less than minus 1, I am going in this direction. So it is same as, because I have to compare with 0 also. So x is less than 0 means you are going in this direction. That means it is same as for this x is less than 0. So what will be its value? Minus x. Okay. Then when x is less than minus 1, its value is how much? Minus of x plus 1. So minus of x plus 1. So that is minus x minus minus plus x plus 1. So it's cancelled, that is 1. Okay, this case is done. Now look at, once more I will write here, x mod of x greater than 0 minus x less than 0. The same thing I am writing here. Just I will copy that. Mod x is x when x is greater than 0 minus x less than 0. Just I have copied here so that I can compare here. Mod of x plus 1 is x plus 1, x greater than equals to minus 1 minus x plus 1, x less than minus 1. Okay. Now we consider x less than minus 1. Now we will consider between these two. That means when x lies between minus 1 and x 0. X lies between these two. X lies between these two. So mod of x minus mod of x plus 1. Mod of x minus mod of x plus 1. Look here, this is x is smaller than 0. X is smaller than 0, that is minus x. So this will be minus x. X is greater than minus 1. X is greater than minus 1. This is x plus 1. That gives you minus x minus 1. That gives you minus 2x minus 1. Minus 2x minus 1. What is third case? Greater than 0. So now when x is greater than 0. Greater than 0. So what is our question? What will be our question here? Mod of x minus mod of x plus 1. So it's very clear. When I say x is greater than 0, mod of x is x. So this is directly x. And what about this part? Look at this part here. X greater than equal to minus 1. This point say direction is this one. This is x greater than minus 1 is same as x greater than 0. So what will be its value? It is same as when I say the direction x is greater than 0, x is greater than minus 1, it is same here. So I will be writing mod of x plus 1 is x plus 1. So this is minus x plus 1. That will give you x minus 1. That is minus 1. Now what I will do is I will combine the question. What is your total summary of this question? Now fx, first part you got 1 when x was less than minus 1. Then you got minus 2x minus 1. I think it is not visible here. I have tried here. Fx equals to 1 when x is less than minus 1. Then you got minus 2x minus 1 when minus 1 less than x less than 0. we got. Then you got -1 when x is greater than -1. Okay. Now let's combine it. Case 1. When x is less than -1, means this side, what is your fx? 1. 1 means constant function, so is continuous. Continuous there is a mistake here. This is greater than 0. Equality here you can take. Equality here you can take. Because x greater than 0 we have taken here. So when x is smaller than -1, your fx is 1. So is continuous. Why continuous? Because it is a constant function. Being a constant function. Okay. Now second part. Case 2. When x lies between -1 and 0. Equality I have not taken. Equality is for the point. So when x lies between -1 and 0, so what is our fx? Fx equals to -2x minus 1. This is also continuous. Why this is continuous? Because this is a linear function. So linear function is also continuous. Is continuous being a constant function. Okay, so this is continuous, this is being a constant function. Now look, third case is when x is greater than 0, your fx equals to -1. Fx equals to, when x is greater than 0, our fx is when x is greater than 0, fx is -1. The -1 is also a continuous function. Is also continuous function. So in the interval we discussed about the continuity. Now we will discuss about the point. Continuity at point. Continuity at point means if I take at x equals to 0, because point is 0, point is -1, so limit, first we can take -1 because -1 comes first. So left hand limit x tends to -1 का left side, -1 का left side. So that is your fx, which is how much? Which is how much? 1. Okay, right hand limit. Limit x tends to -1 का प्लस साइड, -1 का प्लस साइड, -1 का प्लस साइड इज -2x minus 1. How to change the limit? That is limit x h tends to 0 -2 times limit plus h. Limit is -1 plus h minus 1. So how much you got? -2 -1 plus 0 minus 1. So the answer is, that is minus plus 2 minus 1, which is 1. Means left hand limit is 1, right hand limit is also 1. That means we'll go to functional value. Functional value means we'll find what is f of -1. Where you put? When there is equality. You'll put -1 in this. -2x minus 1 minus 2 into -1 minus 1. So 2 minus 1 is 1. That means your limiting value equals to functional value. So this implies limit x tends to -1 fx equals to f of -1, which is 1. Therefore fx is continuous at x equals to -1. Fx is continuous at x equals to -1. Okay, what is the next point? The next point is at x equals to 0. At x equals to 0. So what shall I write? Now limit x tends to 0 minus, means left hand side, 0 minus. This is your 0 minus. So what shall I write? -2x minus 1. So what is the procedure to solve it? Limit h tends to 0, -2 times limit is 0 minus h minus 1. So that will be -2, 0 minus 0, h will 0 will put here, minus 1. That is 0 minus 1, which is -1. So your left hand limit is -1. Okay. Now what is your right hand limit? Now we'll take limit x tends to 0 plus fx equals to -1. So left hand limit is -1, right hand limit is -1. That means limit will exist. So when limit will exist, what we'll do now? We'll go to the functional value, f of 0. F of 0 means where is equality, there we will put 0. So f of 0 value is directly -1. So conclusion, limit x tends to 0 fx equals to f0, equals to f0, means fx is continuous at x equals to 1. I hope this is clear. Okay. Now similar question, I'll take one more. Then if you have any doubt about this question, you can clear it. So similar question means, let's create a question, discuss the continuity of the function. So try to be clear in this question, because same concept you will be using in the differentiability. So differentiability, so question is discuss the continuity, discuss the continuity of the function fx equals to mod of x minus, I'll write here, fx equals to mod of x minus 1 plus mod of x plus 1. You can create any equation. You should know how to find the modulus of this function. Okay, let's keep the concept in the mind. So what is your mod x is x when x is greater than 0, minus x when x is less than 0. I hope you can see, or I'll write with this side, mod of x equals to x when x is greater than 0, minus x when x is less than 0. This is the definition of modulus, already we have discussed. Okay, compare this with this one. What will be mod of x minus 1? Mod of x minus 1 will be, mod of x is x, so mod of x minus 1 will be x minus 1 if x minus 1 greater than equals to 0, that gives you x is greater than 1. Okay, minus x minus 1 when x minus 1 less than 0, the x is less than 1. This is, it is expansion. So what is the expansion of this one? That is mod of x plus 1. Same concept will be x plus 1 when x plus 1 greater than 0, x is greater than minus 1, minus x minus plus 1, x minus 1 less than 0, x is less than 1. Minus 1, sorry. Okay. Now you come back to number line. Number line is what are the values you find? 1 you find minus 1. Because between minus 1 you are finding one value. 1 is 1. 1 means here. So one part of this question is x is less than minus 1. That means you are going this side. Other part is between this. Between minus 1 and 1. This is your x less than minus 1. This is between minus 1 less than x less than 1. This part is x is greater than 1. 3 parts. Okay. So case 1. When x is less than minus 1. This is the only part you have to understand. So our fx is mod of x minus 1 plus mod of x plus 1. Okay, this is the one. What shall I write? When x is less than minus 1, look at here. When x is less than minus 1, mod of x plus 1 is minus of x plus 1. So this comes directly minus of x plus 1. Okay? And look at here. What about this one? When I talk x is less than minus 1, x is less than 1, it is the similar thing. So when I talk about x is less than minus 1, it is same as x is less than 1. You are going this way. So what are you getting here? X is less than 1. What will you get here? Minus of x minus 1. If I simplify, what shall I get? Minus x plus 1 minus x minus 1. 1 is cancelled. What did you get? Fx equals to minus 2x. So first part we are noticing here, x is less than minus 1, the total function is minus 2x. Okay, now another case comes up when x lies between minus 1 and plus 1. So next question will be, when x lies between minus 1 and plus 1. X lies between minus 1 and plus 1. So when x lies between minus 1 and plus 1, that means x is greater than minus 1. X is greater than minus 1. This value will be mod of bit congested, try to see. This is when I say x is greater than minus 1, x is greater than minus 1, modulus of x plus 1 is x plus 1. This is your x plus 1. What about this one? X is less than 1. X is less than 1. The negative part is minus of x minus 1. Minus of x minus 1. Okay? Open the bracket. Minus x plus 1 plus x plus 1. So that is 2. 2 you got. Now third part. Third part is when x is greater than 1. Look at this one. X is greater than 1. So when x is greater than 1, x minus 1, modulus of x minus 1 plus x plus 1 will be how much? Now x minus 1 will be x minus 1. Okay, look. X is greater than 1, x is greater than minus 1. The same domain will have. So what do you find? That is x is greater than minus 1. So that becomes x plus 1. This becomes x plus 1. That means 2x. Okay. So conclusion. Now our fx became minus 2x when x is less than minus 1. That became other part s2 when minus 1 less than x less than 1. Equality I am taking with greater side. Then 2x when x is greater than equal to 1. So this we define into this form. Now we will discuss whether this is a continuous function or not. Okay. See now, when I say x is less than minus 1, x is less than minus 1 in this interval. When x is less than minus 1. What is our fx? The minus 2x. What is minus 2x? This is a linear function. So linear function means this is always continuous. Is continuous. Being a linear function. Being a linear function. Okay. Now when x lies between minus 1 and 1, so what is the value? 2. Fx is 2. This is also continuous. Why this is continuous function? Because this is a constant function. So implies fx is continuous being a constant function. Okay. Now when x is greater than equal to 1 or greater than 1, because equality will take for the point, then fx equals to 2x, also continuous. Why continuous? The same reason, linear function. Now comes up, what are the points we have? Point we will have is at x is equal to minus 1, at x equals to 1. Okay. So let me write that question here. Fx is minus 2x, to 2x. Okay. Now I can do it. So we have discussed about the intervals. So now we at x equals to minus 1. Point when you discuss about the point, you take the left hand limit and right hand limit. So limit x tends to minus 1 का left side. Minus 1 का left side. How much? That is limit x tends to minus 1 का minus side and your fx is minus 2x. What is the procedure to calculate? Limit h tends to now 0 minus 2 limit minus h minus 1 minus h. So if I put h tends to 0, now h I 0 I put here, minus 2 minus 1 minus 0 which is 2. So left hand limit became 2. Let's go to right hand limit. Limit x tends to minus 1 का plus side. X greater than equal to minus 1. So that is 2. That means your left hand limit is 2, right hand limit is 2. To take your functional value f of minus 1, where I will put, now where there is equality there I will put, so fx equals to f2 will be 2. So limiting value equals to functional value. So I can write limit x tends to minus 1 fx, f of minus 1 is 2. Therefore fx is continuous at x equals to minus 1. This is clear? Now, what we'll do is, what is the next point for us? Next point is fx at x equals to 1. So at the point of 1, we will discuss whether this is continuous or not. So it will be left hand limit, same procedure, 1 minus left hand limit, x is less than minus 1, the value is 2. Okay, if I take right hand limit, right hand is greater than 1, that is 2x. So what is the procedure? Limit h tends to 0, 2 times limit plus h, 1 plus h, that is 2 into 1 plus 0, which is also 2. So left hand limit is 2, right hand limit is also 2. Now functional value f of 1 means you will put x may 1, equality is here, so fx you will put here, that is 2x, which is 2 into 1, that is 1, 2. Limiting value is 2, functional value is also 2. So conclusion is, implies limit x tends to 1 fx equals to f1, which is 2. Therefore fx is continuous at x equals to 1. So these are the procedures to solve. So I am giving one question, a similar pattern question. You try to solve. Everybody must try this one. Discuss the continuity of the function fx equals to mod x plus mod of x plus 1. Plus take minus, this plus I have done. So you try to solve this. It is not yet finished. Tomorrow we will try to finish this continuity. Thank you.